afternoon, folks. Today we're going to talk about our use case about on Pinot on Nubank, which is Spark real-time observability. And just introducing a little bit of myself, my name is Felipe. I'm a senior analytics engineer at Nubank, and I have been here for something around 1.5 years, but I have been on the data journey for more than 5 years already. So let's go over our agenda today. First, we're going to begin talking about Nubank's data platform. So how big it is, we have like a lot of customers, and what data problems we are facing right now. Later on, we're going to talk a little bit about Spark Observability, which is our main framework on processing data here. Then we are going to move to Pinot data products. So how did we solve our issues when by using Pinot and building products on top of this blazing fast architecture? And why did we choose Pinot over other frameworks? And later on, the cherry on the top is going to be our awesome results. So folks, let's move to Nubank's data platform. Uh, on Nubank's data platform, we have something we call the daily batch run, okay? So it is one execution of the ETL where we run once a day and it processes all the data sets we have, and we have a lot of data sets. So recently, on 2024, we have crossed the line of 100 million customers, and they are all generating data on every single second. So you must imagine that there's a lot of data to process. And in order to process that, we build our own data platform based on the open source Apache Spark and all our services around the ETL, such as orchestration, such as data catalog and metadata management, were built also in-house. And another thing about our data platform is that data democratization is a core value. So it's a priority of Nubank by having everyone to be able to actually build a feature on the ETL if they have proper training. So in order to keep up on building products, we have made this decision in order to give people the power to build their own products, and we are really data driven here. And besides, we have data democratization, security is a top priority. So we have talked already about the preparation. So people must have a course in order to deploy to the ETL, but we have a huge CI/CD pipeline in order for you to deploy safe your product safely without breaking anything that is already running into your ETL. So in order to serve 100 million customers, we are starting to have some volume issues. Uh, our daily batch runs is handling now some petabytes of data over more than 300,000 data sets. By 300,000 data sets, we can make sure we are running more than 300,000 jobs, Spark jobs daily. So as you may be thinking, already, Spark observability is going to be an issue from now on. Spark observability, resilience, and even observing data lineage. So before we move to Pinot products, let's talk a little bit real quick about Spark observability because I think everyone here is already Spark master, but Spark works like this. Spark is used to process massive data sets. We're talking about terabytes of data, and it can handle that efficiently because we are using distributed processing. So we have a lot of machines where data is distributed, and Spark handles that by sending files across those machines and dividing the workload into really small tasks we can be processed on parallel. The hierarchy falls like this, We first have the driver, which is kind of the brain of the Spark job, and we have the jobs, which are operations, and we have the stages, which are actions such as collection, write, or shuffle operations. And later on, we are going to have the tasks, which is the smallest part of Spark. task is what is processed on parallel on Spark by each one of the cores of our machines. Now we are going to move and talk a little bit about new listener. So why did we not use the open source Spark listener? And how do we actually collect metrics? So since we are talking about tens of thousands of machines generating data on every second, you must be sure that we are generating a lot of rows of data, a lot of metrics every single time. So we build the new listener to aggregate all the tasks on the stage. And instead of sending one message on each one of the tasks, we aggregate like some statistics on stage level, such as median, some quantiles, and we're talking about metrics like execution time, peak memory execution, and the new listener aggregates that on stage level and sends this message to a Kafka topic in order to prevent pressure on HTTP servers, So we're going to reduce a lot the volume of messaging. Okay, so now that we know already about new listener, we are going to see something about our Pinot use case. So we know already that we have a lot of jobs running every single day, tens of thousands of jobs, and they are heavy jobs, and we're mostly using Spark. For people who know already about Spark, uh, it's not an easy task to check and observe a Spark job when it's executing. It has a lot of different metrics, and we have to have some knowledge on interpret on the interpretation of those metrics. So here, by using Pinot, we have made three main products right now. And the first one is platform metrics, which is the most obvious one, right? Since now, instead of having metrics everywhere, such as the Spark UI, we have an analytical database, a OLAP database, which is Pinot, so we can make queries and aggregations at many levels. So by having these metrics on this database, we can check some spikes on data and metrics we like to observe, such as in this card you are seeing right now, we can see that on March 23, our written data is have a commit rate a little slower than the other ones. So this can indicate a malfunction on something. This data is hypothetical, it's not real. But by watching some spikes on our metrics, we can assure the health of your ETL run. So by aggregating like every single machine, we can see beforehand something happens, such as if my ETL is processing data at a slower speed, it may be signalizing me of a malfunction in some of our services. Later on, we have the dataset metrics. This dashboard here is pretty useful because since we have data democratization, everyone can use Spark, but not everyone can handle and interpreting the data that comes out from Spark metrics, okay? So here, by talking to a lot of people and by using my own knowledge on Spark, we made some high-level metrics by aggregating those low-level metrics that we have on the Spark uh, stage metrics and generated a single screen that's going to describe your dataset behavior. So we're going to have some pretty standard Spark metrics here, something like data skewness, which may indicate that your job's performing badly, data spill, which may indicates some other malfunction, and we got some of our own, like linear processing time. And every time that the customer goes to our dashboard and click on their datasets, they're going to see this data here on real time. And what they can see here actually, we're going to see the last value execution. Okay, the most recent one. And as soon your job is processing, you can already see this metric because we are feeding with real-time data. And we are going to compare it to a benchmark, which is the average last 14 days. So you can see if your job is actually degrading over time. And later on, we got the tuning recommendation. This one is our customers' favorites, and we're going to talk a lot about it in the next slide here. And the tuning recommender is used for all people in the bank, all the data engineers here, all the analytics engineer here, and just explaining about how to tune your Spark copy. There are several ways to enhance the performance and the reliability of your data set, like your Spark job. And one of them is you can do it by just adding one line of code, which is changing the shuffle partitions of your data set. So just by adding this small line of code before your data set executes, you kind of changes the way it's going to write your data set, persist your data set in your buckets. So just by doing that, you can actually make your job runs a lot faster. And we have done a lot of experimentation to come with this recommendation, and we have failed a lot to come with the set of rules we have today. So by experimenting with thousands of data sets, we have made a set of conditions on where your data set can be tuned with the partition shuffle, the shuffle partitions indicator. And every time we see an opportunity of enhancing a data set based on several rules, we are going to apply it, and both to improve performance or even reliability. So the rules are coming like this. It's very simplified here in this chart. They are more complex. They have some math involved, some statistics involved, but they're nothing else than a real big query. So if your dataset has high disk skew, you are going to receive one kind of recommendation. If it has high data skew, you are going to receive another recommendation, or high data volume, another recommendation. And we have several recommendations for a lot of characteristics of your datasets, okay? And we have done it to all the datasets in our ATL right now already. So here follows the diagram of how we are collecting the data for Pinot use case. Here we have the raw data, which is coming from our app and external sources. We're aggregating it on our ETL, like we have several clusters with thousands of machines operating daily. And later on, we are feeding it to our data products. Okay, this is the ETL, and all the clusters, they're sending data constantly to the new listener, which you saw before, into a Kafka topic. And it's like pretty easy to connect a Kafka topic to Pinot. It's just an ingestion job and you are good to go. It's like plug and play. After creating the Pinot Spark stage metrics, all we need to do is adding one query on top of the main table here. We have used one big table only, and all our Pinot products based on stage metrics are just using the same source. Now that we know how we build Pinot on a bank, we are going to move on why did we choose Pinot. So by concluding this conversation, we are going to see something like why not use other real-time processing tools, such as Flink as an example. Okay, let's take this as an example, and let's say we have new listener here actually writing data to a Kafka topic, and later on we are going to build one Pinot application for each one of our metrics. So since we have three products right now, we should have like three Flink applications, and every time you build a Flink application, you actually is generating operational burden to yourself, because you have a new service to maintain, to observe, and to fix if they crash, okay? So we have a Flink UI to look out for every day, and every time you need to actually build another product on real time by using Flink, you are going to create a new Flink application. So if I see an opportunity today, I have to develop a new application which will generate another service for me to maintain, another, let's say, Kubernetes cluster to keep this up, and another Flink UI to observe every single day, another set of messages, and another full operational burden, okay? And by using Pinot, we have another approach to build real-time applications. So by using Pinot, we have a real variety of indexes, include my favorite one, which is the StarTree index, which pre-aggregates the data before you query them. So since we have this big variety of index, we can move to one big table architecture. So we can use like a Flink application or other service to feed your Kafka topic, but this Kafka topic is going to be like denormalized data. Since we have a lot of index already, we can pre-aggregate the data by using StarTree index, and this single source of data can be used to a lot of products. So here in our use case in the bank, we have the same stage metrics table here, and each one of the products we have is just another query that we append to this same source. So if I see another opportunity to make another product on Nubank, I'm just going to build another query and plug it into the same source, and it's going to be blazing fast. Since we have like a lot of indexes, uh, the queries on Pinot, they are the fastest I have seen until today. And uh, unlike our other BI tools we have on the market, my customers here, they cannot even see my screen loading. It's like a blink of an eye, the data is already there. So if I need another new product, it's just making like another index here, or even pre-aggregating by using the StarTree index and building another query. And since SQL queries is like main skill for most data folks, like data analysts also, the time to contribution is a lot faster. And now we are going to see some results we have on using Pinot. Okay, so our favorite product here is going to be our partition tuning recommender, which is going to have a set of rules, set of math formulas to recommend your partition. And this is a data set that we had in the past, which was one of the first that we have by example of partition tuning. As you can see here, the data set was taking a lot of time to process, okay? Over 300 minutes processing time. And already know that cloud is not free, right? So after we applied the partition tuning recommender, the job went to something like around 7 or 60 minutes to process. So we got around 80% reduction processing time, which means 80 time reduction on costs. This was the first one. We began to build the rules on top of this. And even after reducing the processing time, we also have increased the reliability of this data set. So this failure rate was reduced to zero. Since this is a critical data set, actually, which feeding some of our products, uh, having this failure rate reduced to zero uh, have reduced the risk of the platform and cost of opportunity for this data set to wait to serve data. So was a big win for us. And this was not luck. After we applied more rules to our ETL, we have found a lot more candidates for partition tuning, and we have around 96% success rate on partition tuning. We did not tune all the datasets, all the 300,000 datasets, because not all of them were fit or able to be tuned because we have some conditions. But for the ones we have applied the partition tuning, we have succeeded uh, 19 out of 20 times. So this was great results even on ETL wise because our landing time of our products was reduced. And by summarizing the results, we have this table here. So applying the partition tuning on all the candidates, we have reduced it already $1 million yearly on cloud prices. So jobs are running faster, they are consuming less resources from cloud, and we could save some money here. And by having this real-time data on Spark stage metrics, we can watch jobs when they're executing. And we have data instance every single day, but severe data instance happens just once in a while. And this year, since we have implemented the Spark Stage metrics on Pinot, we have solved more than 10 data incidents by using the recommendations and even by watching proactively the execution metrics. And currently, our platform, uh, where we made on top of Pinot, is actually have more than 300 users, which are mostly analytics engineers, constantly and proactively checking Spark stage metrics to improve their datasets. So before we have these metrics and this kind of interpretation of metrics, uh, we have no people actively running queries over Spark stage metrics. But now, since we set a new meaning to those metrics and people can actually use it more often, we have enhanced a lot the number of users which are proactively checking the platform every single day. And that's all for today, folks. Thank you all for watching, and I really hope you learned something today. Feel free to add me on LinkedIn or to follow me over my network. And really, I'm really glad to be here today. Thank you, folks. Bye bye.